Alright guys, welcome to Professor Shemba, and today we are going to be looking at differentiation of implicit function. Please take note, often a function f of x, y is specified by an equation in x and y, and that y is not the subject of the equation. If such situation exists, we say that y is an implicit function. So quickly, let me explain what it says. Now, when you look at the previous video that we did, now when we were doing the product rule, when we were doing the quotient rule, the sum rule, and the function or function or chain rule, so you discover that the way the question is always given is y is equal to this, that's y is equals to maybe x square, or y is equals to sine x, or this. But in implicit function, you will not given like that. Y is not the subject of formula. So what you simply do is you when you are given that kind of question, like for example, look at this question now. So when you're given this kind of question, what you simply do is that you simply differentiate every of the variables you are given. You differentiate variable x, you differentiate variable y, and every variable you are given, you differentiate it. Then what you simply do is what you make the y the subject of formula, and when you make the y subject of formula, you have simply differentiate the question you are given. So now let's take an example and see. Now here you have that, well, we have that x cube plus y cube is equal to 3xy. So now you can see, so now you are going to differentiate this, you differentiate this, you differentiate this. So it's simple. So what you simply do is this. Now I want to differentiate this. It's going to be, if I differentiate x cube, I'm going to have 3x squared. Okay, don't forget the principle. Don't forget there's a video I did on how to differentiate some basic function, and there I explained that in differentiating this kind of thing, you need to understand two things. You need to understand what a coefficient is and what a power is. So in differentiating this is the power of the x, and the coefficient of x cube is 1. So you simply multiply the power by the coefficient, which is 3, and you subtract 1 from the power, which is 2. So that is where it is. So then plus you apply the same thing, it's going to be 3y squared. But because it is y, then it's going to attach the y dx. You write it with the y dx. So don't forget, anytime you are differentiating y, always put the y dx. Is very important. Then which is equal to, now this is 3, so you can write this 3 differently. Now don't forget that xy is what is a kind of product, that is, it's kind of product. Okay, so just leave out the coefficient, leave it out. Then you will deal with this x and y. So this x and y is a kind of product, is a product. So you understand how to do the product. The product is u dv. So this, let's say this is my u, so it's going to be u, that's x, then dv, that's the derivative of y. The derivative of y is 1, then it will add to it the y dx, then plus you write y again, then you differentiate x, which will give you 1. So that's it. So then you are going to have 3x squared plus 3y squared dy dx, which is equals to 3. So you can just open the bracket as 3x dy dx, then plus 3y. Now so you can see that we have our dividers here. So what you simply do is what you collect the like terms, you take the dy dx to one side and take the other one to the other side. So here I'm going to have my 3y squared dy dx minus 3x dy dx, which is equals to 3y minus 3x squared. Because this comes to this other side, becomes negative, and this comes here, becomes negative. So what I'm simply going to do here is what I'm going to make dy dx subject of formula. So which is going to give you what, dy dx into 3y square minus 3x, then which is equals to 3y minus 3x squared. So dy dx is equals to 3y minus 3x squared over, that's divided by this, that's 3y squared minus 3x. So you can simply leave your answer like this, or you factorize. 3 is common here, and y minus x squared. Then also 3 is also common here, y squared minus x. So 3 cancel 3. Then your answer will be y minus x squared over y squared minus x. So that is the derivative of the number 1 question. So let's go for that. For the for the For the second one says that x cube plus y cube is equal to x cube y square minus 1. So you know how it is being done. So you find the derivative of this one, which is going to give you 3x square. Okay, then plus this will give you 3y square. You put your dy dx. Okay, then which is equal to, differentiate this. Okay, you write this first, x cube, then you differentiate this. If you differentiate this, is going to be 2y dy dx. Okay, then plus you write this now, then you differentiate this, is going to give you 3x square. Then minus, when you differentiate 1, you have 0. So you are going to have 3x square plus 3y square dy dx, then which is equal to 2yx cube dy dx, then plus 3y square x square. So you notice that you have dy dx. So what you simply do next is that you simply collect the like terms. So if you are collecting the like terms, you are going to have 3y square dy dx minus 2yx cube dy dx, which is equals to 3y square x square minus, this is coming to this side as 3x square. So this is coming to this as negative. So what's common is discovered that dy dx is common. So you factorize and you'll be left with 3y square minus 2yx cube, then which is equals to 3y square x square minus 3x square. So now you divide through by this, so your dy dx will be equal to what? Equals to 3y square x square minus 3x square, everything over 3y square minus 2yx cube. So that is it. So then okay, so that's it. So that's your answer. Okay, so this is the third example. You can see that this is 2 raised to the power of x plus 2 raised to the power of y, which is equal to 2 raised to the power of x plus y. So you can simplify this as this is still the same as 2 raised to the power of x, then plus 2 raised to the power of y, which is equal to 2 raised to the power of x multiplied by 2 raised to the power of y. This is law of indices. I made a video on law of indices, so you can check the video. You can check Professor Shemba, then you check law of indices. You understand better how this becomes this. So what you do is this: you simply say that, you know, in the differentiation of this one is the same as 2 raised to the power of x into, then plus this will be 2 raised to the power of y into, then because it is y, dy dx, don't forget it's important, then which is equals to, now this is kind of product, so I'm going to write my 2 raised to the power of x first, then I will differentiate this one, which is going to give me 2 raised to the power of y into dy dx, then plus I'm going to write, then I will write this one, then I'll differentiate this as 2x into. So what will I do next? So the next thing is I will collect the like terms. So in collecting the like terms, I'll take this to this side, it becomes negative, so it's going to be 2y into dy dx minus 2 raised to the power of x, 2 raised to the power of y, then into dy dx, then which is equals to 2 raised to the power of y, 2 raised to the power of x into, then this will come to this side as negative 2x into. So dy dx is common, so it's going to be dy dx into, that is 2 raised to the power of y into, then minus 2 raised to the power of x, 2 raised to the power of y into, then which is equal to 2 raised to the power of y, 2 raised to the power of x into minus 2x into. So what do? I divide. So dy dx will be equals to 2 raised to the power of y, 2 raised to the power of x into, then minus 2 raised to the power of x into, then everything over 2 raised to the power of y into, then minus 2 raised to the power of x, 2 raised to the power of y into. So which is, now into is common, and what is also common again? Into is common, so it's going to be into, that is 2 raised to the power of y, 2 raised to the power of x, minus 2 raised to the power of x, then over the same into, then into 2 raised to the power of y minus 2 raised to the power of x and 2 raised to the power of y. Okay, so this cancel this. Okay, so which means my dy dx will be equal to, now 2x is common here, 2 raised to the power of x is common, so into 2 raised to the power of y, then I'll be left with 1, then over what's common here, 2 raised to the power of y, then 2 raised to the power of y, then I'll be left with 1 minus 2 raised to the power of x. So that is my answer. Okay, so for the fourth example, so fourth example says y is equals to x raised to the power of x. So what you do is that, now the first thing you do is you take the natural log of both sides. So taking the natural log of both sides, So when you take the natural log of both sides, so you are going to have, so the natural log is the same as in, so it's going to be in y, which is equals to in x raised to the power of x. So according to law of logarithm, this x will come to the back of this in x, so it's going to be in y, which is equals to x in x. So now if you are differentiating in y, don't forget that derivation of in y is supposed to be 1 over y, but because it is y, then it's going to attach the y dx, then which is equal to, this is product through x and in x, so you write x and you differentiate in x. If you differentiate in x is 1 over x, then plus you write this one in x and you differentiate x, which is 1, so which means 1 over y divided by dy dx is equal to x divided by x is 1, so you have 1 plus in x. Okay, so which means that your dy dx then multiply by 1 over y multiply by y, you just simply multiply both sides by y. Okay, so this cancel this, then your dy dx will be equals to y into 1 plus in x. Okay, so your dy dx will be equals to, what is y? Your y is x raised to the power of x into 1 plus in x. Okay, so that is this. So I want to give you a challenge. Try to solve y is equal to try to find the derivative of y is equal to x raised to the power of x, x raised to the power of x, and x raised to the power of x. You can see. Okay, try to do this. So thank you very much for watching. And before that, I would like to say something in case you are confused in this area. So what I simply do here is I simply cross multiply. You might be asking, how come did you get this y again? No, what I simply do is I simply cross multiply. So I simply cross multiply. So when you cross multiply, just leave this out of it. Cross multiply, then you have your y here. So instead of trying to multiply through by y, you can simply cross multiply also and you get it. So thanks for watching. So do well to like, share, comment, and please don't forget to subscribe. It's very, very important. And when you subscribe, do well to turn on the notification button so that you get more of our videos. Thank you. God bless you.